Let's learn everything you need to know about Python and Jupyter Notebooks to work in quantum computing. This website link on QisKit is a good tutorial. I'm going to give it an annotated boost to help you understand it quickly. First, this is a website, not a notebook. I'll show you how it looks in an actual notebook at the end. The website is simpler as first we focus on the Python language. The notebook form is just a package that makes it easier to use Python. Python is a programming language where you don't need to compile. You can just run it line by line, which is how we can use it in a notebook. So if we're quite new to programming, Python is a great place to start. The current version is Python 3, which is what we're using here. One way to code in Python is to use a Jupyter Notebook. This is the best way to combine programming, text, and images. In a notebook, everything is laid out in cells. Text cells and code cells are the most common. If you're viewing this section as a Jupyter Notebook, the text you are now reading is in a text cell. A code cell can be found just below. To run the contents of a code cell, you click on it, and then you press Shift plus Enter. Or if there's a little arrow thing on the left, you can click on that. As this is a website, what we're going to do is click Run. If you are viewing this section as a Jupyter Notebook, you have to execute each of the code cells as you read through. We're going to do this also even though we're reading a website. The code cells run like a notebook, but the text is plain, not encapsulated in a cell. Here we have created two variables which we have named A and B, and we assigned them values using the equal sign. Then we added them. Variable names in Python must start with a letter like A or B, or the underscore character. They cannot start with a number. They can only be composed of alphanumeric characters and underscores. They are case sensitive, cannot have blank spaces, and must not use hyphens. Variables in Python come in many forms. Here are some examples. Integers, floats, which is anything with a decimal component, booleans, such as true, false, string, which is text within single or double quotation marks, and none. In this case, we have, in this cell, code cell, we have comments. See, notice the pound sign on the right that looks like a number sign? This is how we write a comment in Python. A comment is only for humans, disregarded by the computer. I'm going to select Run and run it. And what happens now is these values have just been assigned to these variables. As in addition to these data types, another data structure we can use is the list. We see here a list. When I click Run, these values are now added to this variable called a list. Lists in Python can contain any mixture of variable types. Lists are delimited by square brackets. The equal sign means the variable named A-list is assigned this collection in order. If I select this code on this code cell and hit Run, we get new assignments. And now a list is composed of this collection of data, not the original collection. Lists are indexed from 0 in Python. So how do you access 42 at the beginning of the above list? I'm going to click here, selecting the code cell, hit Run, there's 42. 0 is the index that leads to the first data element. Notice how there's an absence of an equal sign? That's because this statement is not an assignment. It's asking for what is at that index number. Always know when you need an equal sign, when you don't need an equal sign, and when you need two. More on that later. A similar data structure is the tuple. A tuple is delimited by parentheses to distinguish it from a list, which uses square brackets. A major difference between the list and the tuple is that list elements can be changed, whereas tuple elements cannot. So here we have a tuple, and we're asking what is in tuple position number 1. We ask that in the same way we would ask for the index of a list, and we get 42. And here in a list, at position number 5, we're going to change what is there in the list and change that data element. We're going to reassign it from banana to apple, and then we're going to print it to make sure we did get that. Sure enough, it no longer says banana in a list. It says apple. But in tuples, the elements cannot be changed. So when we try to say the same thing to a tuple, we get an error. It throws a specific kind of error, a data type error. Type error. Tuple object does not support item assignment. Also, a difference between lists and tuples. We can add an element to the end of a list using the function append, which we cannot do with tuples because that would be changing the tuple, which is not allowed. I'm going to append this to the end of a list, and then I'm going to print it. So a list dot the function append. Another useful data structure is the dictionary. This stores a set of values, each labeled by a unique key. Values can be any data type. Keys can be anything sufficiently simple. A key cannot be a list, but it can be a tuple. Keys can be integers, floats, booleans, or strings. Now I'm going to run it. And now all of these values have been assigned to this variable called a dictionary. The values are now accessed using the key. I'm going to click selecting this cell, run. This is the key for a value 1 is a string that is the key, and then the value associated with it is 1. This is from the second item in that dictionary. The variable data structure type dictionary here is called a dictionary, and it uses the left-hand side of the colon symbol to identify the key and the right-hand side of the colon symbol to identify the value stored for that key. And then between each entry of the dictionary is a comma. So we can say for each comma the words next entry. You can call the colon corresponds to. So this reads, key named number 1, colon, corresponds to the string that says this is the value for the key 1, comma. Next entry is a string for the key, and the string says this is the key for a value 1, which, colon, corresponds to the number value 1. Next entry is a Boolean value of false for the key, which corresponds to the value of a smiley face emoticon string. Next entry uses a tuple 0, 1 for the key, and it corresponds to the integer 256. End curly brace finishes the dictionary. Dictionaries are delimited by curly braces, and the values are accessed using the keys. So here, when we access the key, We access it like we would an index value. We put it in brackets, again with notice no equal sign. The values for each key are accessed using the keys. And then when this code does not have, in this code, it does not have an equal sign. So that's why we know it is using it for an index field, to ask what is at that dictionary location that goes with the key that is in that string. How do we append to a dictionary? It's very easy. We put the name of our variable, a dictionary, the location, the name of our new key, the equal sign, and the value that we're going to place that will correspond to that key. So if I add this, I have a new key added and a new value assigned to that key. And then we can loop, and then we will be able to find it. New key and new value. Next, I'd like to talk about loops. Now let's talk about loops. Any type of looping is repeating the same command for a set number of times, or until a set value is achieved, or until a specific condition is achieved. The syntax to loop over a range of numbers is for j in a range n, then the statement of the command to be repeated. For example, the print function here means print the value of j. Keep printing the value of j for the duration of the range of the loop. J starts with 0 by default, and it ends at n-1 for range 1. Here, n here is 5, so 5 minus 1 is 4. Let's run it. For every integer in the range, 0 through 4, it assigns that value to the variable j for that iteration of the loop. You can also loop over any iterable object, such as lists. Here's our list. For j in a list, instead of j in a range, we're printing for j in a list, print j. And the same print command is being repeated as the loop goes through each item in the list. As you can see, our new value that we appended to the end of our list, 3.14, is there, and the banana was replaced by the apple when we made that change to index position number 5. Looping over iterable items can also work with dictionaries. For key in our variable named a dictionary, value equals a dictionary key inside of the brackets. That's the position of the index field, which is key. Print key equal key. Print value equal value. Print function. Let's run it. Key equal 1. The value stored there is this is the value for key 1. The second key was a string saying this is the key for a value 1. The value stored there is 1. This third key was a Boolean named false. The value was the emoticon happy face. The next key was a tuple 0, 1, and the value was the integer 256. And then remember, we added to our dictionary a new item, and it was called new key, new value, and there it is. So this is how we use a loop. Now let's talk about conditional statements. The syntax is if, as many intermediate else ifs as you need, and finally an else statement. If something is true, then do something. else it's false, so then do something else. As many else ifs as you need, and then finally an else. So it starts with an if, any intermediate else ifs that you need, abbreviated elif, and then the final else. Here we're, so notice here several things. We're using, first of all, a double equal sign. This is different than a single equal sign. Double equal sign means comparison. Compare the right-hand side with the left-hand side. If they are the same, then the result is true, and execute the following statement, which is a print command. If the result is false because they are not equivalent, then go to the next statement, to the else statement. In addition, notice that we can refer to the entire list, searching all of our variable named a list for the strawberry. Or we could locate and search just one location in the list where we go to index location number 5 inside of a list and look for that apple if it is located at position number 5, index position number 5. Let's see how this runs. We have an apple. If you recall, in our list, we did replace that banana with an apple. So we never had a strawberry. So it searched the whole list, did not find a strawberry. So the first statement resolved as false. So it skipped down to the next elif command and looked for the apple in position number 5. It found that it did a comparison, found apple is equal to what is located there, and it printed, we have an apple. That is now true. So now it ignores the rest of the statement. Now let's talk about importing packages. Importing packages is done with a line such as import numpy. The command is import. I'm going to select the cell and run. Now numpy is installed. A package is code already written for you that contains functions and methods that are already ready for you to use. The numpy package is important for doing math. We have to write the package name, numpy. Here's the syntax for using a package. Numpy comes first, that's the name of the package, then a dot, then the name of the function or method inside of numpy. We have to write numpy in front of every numpy command so it knows how to find that command defined in numpy. Here we're going to use the function inside of the code package numpy to find pi over halves. And the function is in the parentheses, putting the value there. So that is sine numpy halves. It's a pre-calculated value for pi in the numpy package. To save writing, it is common to use a statement such as import numpy as np. That's abbreviating. Then you only need to use the shortened name. It is very common to use the shortened name np instead of saying numpy. And this command does the same thing as the earlier one. I'm going to select the earlier one, select run, and we have numpy dot pi halves, and we get the answer, which is for the sign, which is 1. And if I do the same thing, numpy as np, and we have np dot sign, and I run it, I also get the same answer. You can also pull everything straight out of numpy and by using from numpy import star. But this can cause packages to mess with each other because you may have different commands in them that are similar in name, which would confuse the computer. But we can hit run, and now we have NumPy. Everything star has been imported from NumPy. Then I don't need to say np or numpy dot before using the function sign, and I can run it and get my answer. If you want to use trigonometry or linear algebra, you use NumPy. For plotting, we use the package matplotlib. For graph theory, we use networks. For quantum computing, we will use QisKit. A good thing to know about in any language is how to make our own function. Let's talk about functions. We've used the function py that was inside of the NumPy package, and we have used the print function. Let's make our own function. A function is just a piece of code that we can use and reuse by calling it. Just creating a function without calling it means nothing will happen. Note the command word return. It means that we used it to get the value out of the function, so that when we print the function, we get the value. If we did not return anything, printing the function won't do anything. Here's a function whose name was chosen to be do some maths, whose inputs are named input 1 and input 2, and whose output is named the answer. It's used as follows. The syntax is the special word DEF, which means definition. So this is followed by the name of the function being defined. So in this case, we have input 1 and input 2. We have run this, so the function is now ready to use. And we're going to use it by calling this function, do some maths, giving it in parentheses what we want it to do for input 1 and input 2. And we know this function is going to add them and return the answer. And this is how it's used. It added them, and it placed the value here. So this function, do some maths, is now ready to use and reuse anytime we want to add two inputs. Now, if you give a function an object and the function calls a method of that object to alter its state, the effect will persist. So if that's all you need to do, you don't need to return anything. Now let's look at something with the append method of a list. Define, and we're creating a function, add sausages. And we're making the parentheses. And we're putting there what we're going to do. Using that special word, define, def. And then we have our statement after the colon. If sausages is not in the input list dot append sausages. So this is called a method because we're taking input list and we're putting the dot, and then we're having append sausages. We don't need to return it. It's just adding to whatever is in that list. I'm going to run it. So the code is now ready to use. Now, we have placed input list as a variable to be used to add to the list. And now we're going to use it here, this new function that we've written called add sausages. First, we're going to print the list before the function. We're printing a list, our regular list that we've been using. Now we're going to use our function, add sausages, parentheses, a list. So it's going to take this function and work and operate on it using a list, because the list that we have is taking the position input list. And so this comment says the function is called without an output, so nothing happens yet. Then when we print list after the function, we're going to then print the list after we have used our function. So I'm going to, in this \n means new line. List before the function, a regular list. List after we use the function and we added the sausages. Let's look at another package called the random package. Let's loop through separate functions of this random package. First, we import the package. So I have to run this to import random. And we have here a loop that's going to iterate with random package and get some results for us. As it loops, it's going to start with, remember J is always default 0, but in this case, it's going to say 0 plus 1. So it's J, whatever J is, as it loops through 0, 1, 2, 3, 4, it's going to say plus 1, so it's going to present the new number. And then we're using a package random that we've imported, dot, and a method out of it called random. That method, that function is going to pull a random number between 0 and 1 and put it there next to this string that we have. And then we're going to do the same thing and randomly pick from our variable called a list. We have quite a few things in our list. We have 42.5 true. We have another list. We have none, apple, 3.14, and sausages. We want to use this other function to pull a random choice from our list. So let's see how this works. Results from sample, and this we get 1. Random number between 0 and 1, 0.85. Random choice from our list, 3.14. Result from sample 2, a random number from 0 to 1, and then we have a 0.08. A random choice from our list, the integer 42. Result from sample 3, each time these methods, there are 2 methods that are working, and we're iterating through them, but random package just uses those random methods to pick from them. 3.4, 5, and 0 and 1, the other list. All of them and all of our random numbers were different. So that's how that's how you loop through the 2 separate functions of the random package. These are the basics. Now, all you need is a search engine. Now, I don't recommend that you go to Stack Exchange or Stack Overflow. What you need to use is Google. When you use Google to look for a new question that you're finding, you will find the answers very quickly in Python because it is one of the world's top languages to answer your follow-up questions. But this is all the Python that you need to know in order to do quantum computing. Let's use another example to understand dictionaries, also to show you how the code looks in an actual Jupyter Notebook. As you can see, the name of this file has a Jupyter Notebook extension of IPYNB, which means Interactive Python Notebook. Here's a dictionary with the first 3 keys of 1, 2, and 3 as integers, and their values are red, green, and blue in order. The next 3 keys are named red, green, blue, and their values are 6-digit hexadecimal codes. Now let's run the same loop we used earlier to iterate through the dictionary items. We're going to click, since we're on a Jupyter Notebook, we click at the arrow to run the cell or select Control-Enter. And it is clear now, as we iterate through the dictionary items, what is a key and what is its corresponding value. key 1, red, key 2, green, and then these following values. Now let's practice appending to the dictionary with this item, black. To append to a dictionary, you use the name of your dictionary, put it in brackets, whatever you're adding, then the equal sign, and then the value that will be assigned to that index field. And now I have to click on this to run it. I run it. We don't see anything, but we know the assignment has been made where this has been appended to dictionary. And now we go to our next code cell and we click it to run the cell. And now we have the same loop has been iterated through, but now it shows also our new value and new key, black, and the new hexadecimal code that goes with black. Now, I would like to show you also some other items that make a Jupyter Notebook easy to use. You can select cells and run them by clicking on the left-hand arrow, which I just pointed out, or you can, I'm going to take these out so that this part has disappeared, or you can go up here to Runtime and select either running only one cell that you've selected or run all of the cells. Here, it's now running all the cells together, so you don't have to worry of skipping one. Also, on the right-hand side of a cell, you can select to move it up, so that cell moves up or down. And also you can add comments and links to cells. You can add cells easily, and you can add text. You can add a new cell, which adds a new place to write code, and you can write a new text where you just put in some text that helps annotate your code. And you can also delete as needed. So I'm going to delete here, and I'm going to delete here. So this finishes my example. One more thing. You can save it in GitHub. You can save it in your Google Drive in this case, and you can just download it either as an interactive Python notebook or as Python code, straight code. And here I can share it. I'm using this Python notebook in Google Colab, so I can share it with anyone that I want to, either as a view only or as an editor, either sharing them with them the files so that they can access it and edit it, or only the link. Okay, so this is what the Jupyter Notebook looks like that we will use our Python in. And that's all you need to know to do quantum computing using Python and Jupyter Notebooks.